Hi everyone, my name is James Spiteri. I'm on the product marketing team for Elastic, focusing on our security solution. I'm here today to run you through a very extensive demo about Elastic security. I am a security practitioner at heart. I've been doing security operations, incident response for about 15 years now. Why am I on a product marketing team? Because of videos just like this. I really enjoy demonstrating our product and making teams and users excited about wanting to use it. So that's what we're going to be doing today. If you're here as more of an introduction to Elastic, or perhaps trying to find out what we do in the security space, this is probably not the right video for you. So I will just point that out. I will be linking some other content in the description. If you want to just dive right in, see the product in action, go through a full incident response for the next couple of minutes, then keep watching. This is a great video for you to watch. I'm not going to be sparing any detail. We're going to go through the whole thing as long as it takes together right here. So sit down and enjoy just as much as I'm about to enjoy presenting this to you. And with that being said, let me go ahead, share my screen and kick this off. So a bit of context. I am running multiple Elastic clusters in our Elasticsearch service. Some of you might know it as Elastic Cloud. Call it whatever you want. Why do I run multiple clusters? Because I have different data sets in different cloud regions. You can actually have them in different cloud providers. And to save costs of switching data around and transferring it, I can view them all through one screen with cross-cluster search, which is exactly what I'm doing here. At the same time, each of those clusters has a couple of Elastic agents reporting into them with several different integrations, which is why I'm actually on the screen to walk you through some of those. I always like starting off with the integration side to see what we'll be working with as part of the incident response. Now, I'm just going to say, whilst the Elastic agent is the most streamlined and the easiest way of bringing data into the stack because of the management and all the features you get with it, and you have additional features like Endpoint Security and osquery manager integration right there, it's not the only way. If you have a different and preferred method of bringing data into the stack, that is okay. If you have an existing EDR or endpoint provider living within your infrastructure, that is okay. That is totally fine for us. A lot of what you'll be seeing will work just fine. There are some views which are endpoint specific, or I should say Elastic Endpoint Integration specific, but you can send data from other sources. Just want to clear that up from the start, just in case. I don't want you to walk away from this video feeling, we have other ingestion mechanisms. I can't do anything of what James showed me. It's not the case. With that being said, let's take a look at our integrations here. So I have a policy named Linux. This demo is going to be very Linux heavy. Most of my other demos are very Windows focused, but we've been really busy with several new features for Linux workloads and cloud environments, as well as improving the analyst workflow. So that's why I'm going to be focusing on Linux today. Plus, why not? There are some really interesting things we can get out of Linux, and the threat landscape is there as well for Linux. So what do we have here? We have some custom logs, because as much as we all enjoy using out-of-the-box content, every production environment is going to have a custom log integration. Let's face it. And in this case, I have some Java apps. I'm just ingesting their logs. And I've been testing out SysMon for Linux, so I'm just bringing that data in as well. We have file integrity monitoring. We have endpoint security. We were collecting data at the network interface level with our network packet capture integration. We're running osquery manager, which is amazing, and we're going to use it all over this investigation today. Plus, we're running our system integration, which is going to bring in your native Linux system logs like varlog messages, varlog secure, auth.log, whatever you may be using. Before we dive into the incident, I'm just going to dive a bit deeper into the endpoint security integration, because it's not just about data collection. You do get native protections. So whether that's file-based malware, memory threat and ransomware preventions, plus malicious behavior protections as well. So we have a set of rules that run on the endpoint which look for specific behaviors. Now, as you can see, everything above this line is in detection mode. My behaviors are in prevention mode. So this is the policy this organization decided to adopt, which isn't totally uncommon. Some people are scared of prevention. So in this case, I am doing that. Plus, I am collecting everything, including the new session data view, or I should say the data to power the new session viewer, as part of my policy. So I just wanted to highlight that real quick. We're now gonna dive right in. So what am I doing here? I have a colleague who's on our security operations team, and they reached out to me to say, hey James, listen, I'm currently inundated with some other incidents. I've created a case and attached a couple of alerts, which I'd really appreciate if you can look at them for me today. So I can see here within our detection and response dashboard, we have a case which is opened by Michael Scott today. And we have a couple of alerts we're dealing with. I can see some of like a summary of the most critically, I should say, highest severity alerts. We can see the hosts involved, users involved, all of that good stuff. So what I'm going to do is I'm going to go ahead and click on this case to see what my colleague has told me. So, saying, hey, James, as discussed on Slack, and he's linked me right to the Slack message. We can do this thanks to our markdown syntax. Please investigate the attached alerts as soon as you can. Sure thing, Michael. I will go ahead and do that. So first thing I'll do, I'm going to change the case status to in progress. And as soon as I do that, because we have our alert synchronization enabled here, all the attached alerts are going to change to acknowledged. So all the 14 alerts are now marked as being worked on. And I'm going to dive right in. So there's a couple of ways I can start investigating these alerts. So we see we have quite a few here. I don't know if they're all related yet, but Michael did add them onto this case. I can, if I want to, start going through the individual alerts here. For example, I can just open up the alert overview and get the details here. We do now also include an alerts table. It is still in technical preview as we add more functionality to it, but I do have this sort of view if I wanted to. The way I prefer working is I tend to pivot still back to the native alerts table. It's just me. You can do whatever you like, but I'm telling you, I'm going to run through this incident as if I was as part of security operations team today. So I'm not going to change my workflows just for a demo. I'm going to run through it as if I was using Elastic in my day-to-day, which I still do as a hobby. But let's go through this together. Okay, so here are all my acknowledged alerts now. You can see I actually changed from the open to the acknowledged queue. There are other alerts, by the way, not just the ones I was working at. Let's face it, in a typical environment, you're going to have multiple people working on multiple different alerts. So there are some others which weren't as part of the case. I'm not going to focus on those. Someone else is working on them. I'm going to focus on what Michael asked me to take a look at. A couple of tips from an Elastic standpoint when you're going through some alerts. So you can see I actually have multiple timestamps in this table. We have the timestamp value of when the alert was generated. So remember, all the alerts we give you, those 600 plus alerts that come out of the box, they all run on a schedule, or any alerts you create as well, right? They all run on a schedule. And this timestamp is reflecting the time at which they were detected after the schedule ran. What I like to do is I like to add another column. I like to add the original event time, which is basically the time at which the event actually happened. So regardless of the schedule, here's when it actually happened on the day, at the minute. And you can see here, it paints a nice picture that they all happened within very close proximity of each other. They are all happening on the same host, by the way. That's a column included by default. And yeah, and you can do this really easily by just clicking on the fields option, adding any field from the list that you want. Or another tip for you, you can create custom fields on demand here. So if you were missing a field as part of your log sources, you forgot to parse something, you want something additional to what we provide as part of the fields out of the box, just click the create field button from here. This uses the runtime field option in Elastic. That can be as simple as writing text in a new field. You can do some mathematical computation. You can write fully fledged scripts if that's your thing. But what I want to point out is you can have it right as part of your workflow through this menu. So that's a little tip of what I like to do, but now let's start going through these. So again, for each one of these alerts, I do have a more details option. We can look at our timeline, which is totally okay. What I like to do though, is I like to start off looking at the reason field. What's it saying? For these two alerts, these are actually machine learning based. So we provide about 60 or so rules which are based off of our unsupervised machine learning, which is basically learning your data over time. In this case, it's looking at network and process activity, and it's trying to identify what's not normal in your environment. So we've given you a hypothesis to say, hey, here's a job. Let's model unusual network behavior, specifically port behavior. And in this case, it found two events where it's saying, listen, Java on this machine typically doesn't connect on port 888 and port 1389. Okay. I can, if I'm interested, I can get all the mathematical detail. So I can look at like probability statistics, that sort of thing. I can see as well what host it connected to. So there's 10.132.15.213 address. And if I wanted to, I can get more information about what this port may be. I can click on this IP and get more information about that. So everything is contained right within here. Again, if I'm interested in mathematics, all of that is provided. So we don't hide any of this stuff. It's not, we don't like that black box approach. So these two alerts are telling me something's going on with Java, followed immediately by a suspicious Java child process alert. Let's take a look at this one. So I'm just going to go on this view details button here, and I can see quite a bit of detail. I can see all the arguments that ran as Java, with the parent process of Java, I should say. And it's a lot, right? So there's a couple of downloads, compilation of stuff, changing of permissions. It's a doozy. There's a lot going on. What I like to do though, I like to read everything that Elastic has given me, or my rule authors have given me, because it can be Elastic, or it can be the community, or it can be yourselves, about this rule. So again, let's look at this. I'm going to open this in a new tab for simplicity's sake. And I'm going to see what Elastic has told me about this rule. So again, you can actually see the whole query, so we don't hide what we were trying to look for. Give a description about the alert, MITRE attack tactics and techniques, and reference URLs, which are very important, right? Context to why this rule was created. Before I even click on any of the URLs, all I can see here within the paths are log4j 0-day, log4shell, JNDI LDAP manipulation, which anyone who's worked at least over the last 6 months in security operations, you all know where this is leading, right? Even before I click on the links, this is probably related to log4shell. Again, log4shell, very, very terrible unauthenticated remote code execution exploit, which was discovered in the world's most popular logging library. So pretty much everyone was impacted. So just by looking at this, I'm going to theorize that this might be a log4shell exploit attempt. It's still a theory. So when you're doing through incident response, that's part of the process, right? You have to theorize about what you're going to look for and come to your root cause analysis and investigation. That being said, we've started to include a lot of investigation guides with our rules. Not all of them just yet, but we'll get there. But there's a couple of hundred or so that will ship with an investigation guide, which will actually tell you exactly what you should potentially be looking for. So which is pretty cool. And this one is just giving me some detail about data collection. But in this case, I'm going to go off the log4shell hypothesis just because of these links. Okay, so let's dive into that. Let's hypothesize that this might be log4shell. Now, I'm going to look at this in context. I'm going to launch what we call our session view now. So our session view is actually going to show me where that exploit happened as part of the wider session that started off by this user Java. Look how cool this is. It's as if I'm in the terminal at the time that I'm being exploited. I have all the detail in the world. I can see how many other child processes there are that are causing me to cringe already, but they're all there. I don't have to pivot my investigation. I don't have to run another search. I simply click one button and I have all this detail to work with, including other alerts, which might be the other alerts we're supposed to be looking at as part of the case. They might be already here just by clicking that one button. This view will also show me if there are any privilege escalation attempts or user change events, which might be relevant to our investigation as well. So I'm looking at this in context. I can see that it ran successfully because it has child processes which look like what should be run based on the command line arguments and the process arguments here. But for this to have been for my hypothesis to be correct that this is Log4Shell, there has to be Java libraries running, right? And those Java libraries, I should say Java files, should be running Log4j classes. If they're not, then this might not be Log4Shell. This might be another Java exploit. How can we confirm this? So I'm going to use osquery. If you're not using osquery during incident investigation, you're really missing out. What it allows you to do is run ad hoc queries on a host, as if you were on the host, but natively from Kibana. And it really helps during investigation. We integrated this right into Elastic Agent. It was initially developed by Facebook and still is maintained by Facebook, and they open sourced it, so really kudos to them. But let's run a query together to confirm if I have these libraries on this system. Because if I don't, time to pivot off to a different hypothesis. I have a saved query here. So we do provide quite a few saved queries out of the box, which you can choose from. I'm actually going to use a community one, which was shared by a company called FleetDM, which also creates software to manage osquery. This is an incredible query, which really highlights the power of osquery. So what this is going to do is it is going to check for every running process to see if there are jar files. If it does identify jar files, it's going to grab those jar files and use a Yara signature to check for those libraries we're interested in. Let's go ahead and do that. So I'm going to run this. And without having to need access to the machine, right? And we can see there are 4 rows returned. And unfortunately, yes, it does seem like we are running the Spring Boot application here, which has the log4j Java class as well as the log4j JNDI lookup class. Not good. What I'm going to do is, because we have a case opened, this is evidence I'm going to want to put into my case. I can do a couple of things with this. So first, I can add them to my timeline. So if I wanted to pivot my investigation, search some other data sources, correlate, that sort of thing, I can open a timeline right from here. I'm going to do something different. I'm going to use Lens to save this as a data table so I can include it in my case, because you can include visualizations in the case. So let's just do that real quick before I continue investigating this potential Log4Shell exploit, because we're not done yet. Just because we have libraries doesn't mean that it were exploited successfully. So we're going to still go through that. Actually, before I do this, I'm going to make my life just a bit easier. I'm going to run this again, but this time I am going to use this really cool ECS mapping feature to map the results instead of matches and path to the correct ECS equivalents. ECS, by the way, is our Elastic Common Schema. So we give you this UI so you can map osquery schema to ECS. So in this case, I'm going to use file.path and map that to path. And I'm going to use file.name to map that to matches. This is just going to simplify it for me. So I'm just going to submit it again. So I get the ECS equivalents this time. We can close this Lens tab, which was opened. And we're going to view a Lens again. Why did I do that, by the way? Because I told you I'm not skimming on any details. I'm going through the whole investigation as if I'm part of a team. I think that's really important for you to see. So first thing I want to do, by default, Lens will give you this pie chart, which isn't, what we want for a case. So I'm just going to change this really simply to a table. And then I'm going to include those 2 ECS fields. And Lens works just with drag and drop, right? So I just need to do this. There's no typing, there's no querying, just that. And the next is file.name. I'm just adding that to our table. That's it. I'm not interested in this count, so I'm just going to hide it. Easy. And I'm just going to change the names of these so they're nicer in a case. I think aesthetics is very important. So this is file.name. So we'll do just name the column Java library, and this will be jar path, and this is going to be agent name. Okay. All right. Now I'm going to save this. so I can reference it in our case. Don't have to do this just yet, but I'm just gonna save it. I'm not gonna add it to a dashboard, and we're gonna call this James L4S investigation. Save and add to library. Okay, so I've done that. That is, so I later added to the case. But before I added to the case, I just want to go down this hypothesis a bit further. With security data, I'm a bit stuck. I can't really continue continuing to confirm that this was an actual Java application which was exploited. What I really need is access to a different kind of data set, which is where we start to talk about observability data. What is observability data? So we're talking about things like application logging, application metrics, application performance monitoring. So literally checking exactly what my application did at every single stage that it runs. Now, typically in a security world, you don't have these available to you. They're not in the same platform. You would have to get in touch with another team, grab the phone, add it to the case and wait for that to respond. It's not an ideal investigation workflow, right? But thankfully, my organization, we use Elastic, security, and observability. So I'm going to pivot just by clicking this menu button into observability. Literally just clicking here, and I'm going to switch to APM. I want to know exactly what my Java application did at the time I'm assuming it was exploited. Because again, if I see stuff which doesn't look for Log4Shell, then I don't want to add that as my hypothesis, right? Now, obviously, again, in a full production context, you're probably going to have hundreds of Java services. In my case, I only have one. So do filter by the process ID that we provide in the security view or anything else, the host name. Use that query bar, because otherwise it's going to be a bit messy. But in my case, I just have the one, so I'm just going to click on it. So I can see this is a Java application running on a Google machine. And then I have this list of transactions. So this is exactly what the application does when it's being used. Legitimately or maliciously. In our case, we're assuming there was a malicious intent. So I'm going to click on this transaction. And what's this going to show me? Well, this is going to show me what happened when my application was what we feel or believe to be exploited. So the first thing we see is that my application responded to a HTTP GET request with a 200 OK. And if I click on this, we get all the web details. You remember saying, James, can't I just get this through web application logs? It's very normal that we collect it in a SIEM. Absolutely, you can. But when you're using APM in this case, you're going to see how this data is going to interact with the rest of the APM data. Plus, you don't have to worry about things like parsing. You don't have to worry about things like field names or just dedicated views like we have here. So again, pick your poison. In my case, I really like this APM view. So scrolling down here, what I'm really interested in is seeing these HTTP headers. Now, let's look at this, right? I can see here, just immediately, we have this X API version header. And then the content, this doesn't look like an API version to me. I don't know about you. This looks like a very long base64 encoded string, prepended with JNDI and LDAP, which again, within 10 seconds of Googling for Log4Shell, this is exactly the sort of payload you're going to find. Okay, that's already not a good sign. But let's look further, because so far it just seems like this attacker sent the request. What happened after this was digested by my Java application? Well, there was a GET request to the IP that we saw in the machine learning results. Remember that? We saw it say you had unusual port activity to port 8888 to this 10.132.15.213 address. That was successful, so our application reached out to that IP, successfully downloaded this exploit.class, which is exactly what Log4Shell does. So unfortunately, this is extremely indicative of Log4Shell at this point. But one more thing I'll do is I'll check our stack trace, because this, yep, you can see it was actually invoked by the log4j JNDI manager lookup. This is not something you get from weblogs, right? We have a full stack trace here. And we also get two more views of dedicated log viewer, because again, for log4j to be exploited, our application has to be logging with log4j. So we can actually see here, if we scroll to the top, we do see our application by design logs the API version header. This is that custom log we saw in the very beginning in the integrations. And again, we see exactly what was passed to the header, right? So very indicative. And we have this, last thing I'll show you in the observability view is the service map, which is showing our Java application connecting out to there. If you had multiple services as part of your wider application ecosystem, you will see all of that here. And if you typically don't see a random IP address on a random port that your Java application is connecting to, that is almost an immediately indicative sign. Okay, we've confirmed 100% now this is a log4shell exploit attempt. Time to update that case, right? Really important. So let's go back and let's go to cases. At this point, this is no longer medium severity. This is critical. This was a production Java application exploited. I'm also going to do a couple of things. I'm going to synchronize this case with Jira. Why am I doing that? Because now it's time for the wider business to be aware of what the heck is going on here. It's a critical security issue. I might need to involve other teams now. We might need to lock down that machine. Might need to get other people involved. So Jira is going to allow me to do that. Not everyone might be looking at Elastic, right? We're going to give this the highest priority. I'm going to save that. And now I can synchronize this with Jira. Before I do that, I'm going to say, based on initial investigations, looking at both security and observability data, this looks like a successful log4shell exploit attempt. What I'm going to do is I have this page open. So I'm going to steal this link that Elastic has there. I'm going to add that as a link here so people all are aware of the significance of log4shell. And we're going to attach that chart. Attached is the list of running jars on this machine which were exploited. Just click this button. I'm going to search, that was, what did we name it? Log4 L4S, right? Yep. Add that. We already built it, so we don't need to do anything here. Just let it load and hit save and return. We'll preview it just to make sure it looks okay. And there we go. So we have everything we needed. Add the comment. And we're going to push this to Jira right within the case. Okay, we've done quite a bit of work, but I'm telling you, we have way more to go. I thought this was going to be a long video. We've only started with one alert. Let's continue that investigation. So let's go back to the alerts view. And let's open that session viewer again to see if these other alerts are involved. Another quick tip for you. You might want to use our event rendered view. I've spoken about this quite a lot in the past. I love this view because it plays things out like a story for you as well. But in this case, I'm just going to focus on session viewer for a bit more because I think they're all part of the same session. So we're going to open session viewer again. We're going to go full screen. I'm going to look at the alerts here and just quickly hovering over these. If you have a keen eye, most of these would be what we have in existing alert table. So I might save some time by using session viewer. So let's go ahead and do that. Okay, so we can see that there were a lot of child processes run, and then I have the next alert at this compilation event. Now, okay, you might be saying, why the heck do you have GCC on a production Java machine? Very valid point, you should not. Remember, security operations, logging, SIEM, that is something you should do secondary. You should do all the basic stuff first. Harden your systems, patch your machines, all of that stuff. In this case, there are some no-nos, like having GCC on a production machine. So keep that in mind. It's not just about SIEM. And we have this malware detection alert here. Remember, we're running our endpoint security integration. Now, what is this? So it seems like as something was being compiled, we detected it. When I say we, as Elastic, we detected it as malware. Let's look at this. Now, on Linux, under the hood, we're using Jira signatures. So I have a very detailed blog post about how we generate those signatures. So do check that out if you have the time. But one thing we include is the rule name for that signature. So I'm going to take a look at this table here, and I'm going to search for rule name. And this is saying this is Linux exploit CVE 2022-0847. Again, if you're an incident responder, looking at this alone might make you twitch if you have a good memory. But I want to see more detail about this. So just as I would do an investigation, I am going to grab this and I'm going to Google it. And let's do that. So let's Google there. And let's go on the first link. This is looking like something that was dubbed as dirty pipe, which is not good. Basically, it leads to potential escalation of privileges if you have a vulnerable kernel version. I want to search for something else though. I want to check what Elastic has to say about this. We recently launched our Elastic Security Labs webpage, which is basically all our research that our teams do. So we have loads of really experienced researchers, which are of course contributing to the rules and the detections that you just saw in the product, but they give a lot of their research back. So let's do that. Let's check now for the CVE in Elastic Security Labs. And here we go, detecting and responding to dirty pipe with Elastic. This is all available to anyone, whether you're an Elastic user or not. Elastic Security Labs is there for you to use. Now, why am I doing this? Because probably within Elastic Security Labs, Elastic is going to tell me how I can check if I'm vulnerable to dirty pipe using Elastic. And again, they're telling me to use osquery here, so we're going to do that. Basically what they're saying is, or the research they've provided, is if you have a vulnerable kernel version, which impacts between 5.8 and these versions, so 5.16, 5.15, 5.10, and their sub versions, then I am potentially vulnerable. So I'm going to use osquery to do that. You might be asking, hey, James, it would be really cool if we had this right in the product. Stay tuned. That's what I'm going to say for now. But let's go back to alerts. And again, we're going to run osquery. And this time, I'm not going to use a safe query, but I am going to run what there was in the post. So select star from kernel info. Submit. Fingers crossed that my kernel version isn't vulnerable. But unfortunately, as many fingers as I have crossed, I do have a vulnerable kernel version. So 5.11 is a vulnerable version. We have these results now. We can add them to the case. We can go ahead and do that. Just to save a little bit of time on this demo, I'm not going to do that because we've seen how we've done that. So I'm just going to write a comment that we do have a vulnerable version. I haven't confirmed if the dirty pipe exploit ran, right? So let's just see that. So based off of this, based on the fact that we have a vulnerable kernel version, I might potentially see a privilege escalation attempt. So I'm just going to scroll down, see what else happened. We have another alert, which is again related, same malware. Probably as it's being built, we detected it again as the file is moved around and written. And lo and behold, we have exec user change to root. Unfortunately, it seems like this dirty pipe exploit was run, and now this attacker has root privileges on this machine. So not only did they exploit Log4Shell, went from Java to root, they now have full access on this machine. So what does an attacker do when they have full access? They try and establish persistence. They might try and steal some data or exfiltrate data. They might try and ransom us. So who knows, right? So let's see what they've been up to. I'm saying all these things based on the alerts I saw, right? We saw some indication of this. So let's see what they did. Thanks to this amazing session viewer, I pretty much have a literal, almost terminal style view of what the attacker did, or what his scripts did, or their scripts did. So we can see they ran this additional script here, which was downloaded in the initial request. We have some alerts here. We have an alert saying possible data exfil using Slack. This is one of the custom alerts I built for this demo, because again, you are definitely going to need some custom alerts within your environment. What is this looking at? So just looking at this process and its arguments, it seems like Slack was used to send a message to a channel. The attacker included their bearer token, they probably didn't know that we'll have access to this level of data. But I'm just going to show you why I built this rule and how I built it. So I'm going to go to the rule details. And just to show you what I've done, okay, because I think it's important. Again, I didn't want to hide anything. So I'm using EQL, our event query language, and I created a rule which is basically going to look for two things, and it's going to correlate across two different data sources. So I wanted to see if there was a process which is not Slack, right? So very important. I don't want to, see Slack requests from Slack. I wanted to see processes which are in Slack and have the arguments of slack.com. So think of, like we saw in our case, we saw curl making connections to slack.com. And I wanted to see if that same process correlated by the process ID had successful TLS connections to the domain slack.com. Remember, we have that packet data, which also does TLS handshake collection. And this is what this query is looking for, and we had results. So unfortunately, it seems, because of that correlation rule, that this connection not only was attempted, but it was successful. And then we had a couple of other alerts where it starts to get a bit interesting. So we have 3 alerts, all the same, saying potential reverse shell activity via terminal. You never want to see this, right? Obviously, this person has root access, which means they can do whatever they want. If our machines aren't hardened, well, even if they are, they're root, right? They've gotten far enough where it doesn't really matter anymore. But why would someone establish a reverse shell? Because they want to do whatever they want to do without relying on scripts now. If a reverse shell is successful using native Linux shells like bash, zsh, ksh, whatever it may be, they can type in their own terminal as if they were typing on our machine. Now, there's a rule here which is labeled as rule detection. This is actually one of those behavioral prevention rules running on the endpoint. So remember when we saw our policy, we had behavioral rules in prevention mode, which means technically this should not have been successful. So we're seeing here that this shell activity by bash with parent process pawncheck.sh, which is the script this was using, we detected it as shell activity, I should say reverse shell activity, and hopefully we did prevent it. Now, we do contain details here, but within the context, and I'll show you some other alerts. What I want to show you is how you can use osquery again for this. I told you I'm going to be talking about osquery a lot. So I created a saved osquery search, which does just that. But I'm going to need a few things first. I'm going to need the support number. So this attacker is trying to connect to this server over port 2323. And I'm going to need the process ID, the PID, which if we look at the detail panel here, sorry, that's not what I want. I want the process detail. This is port 4013555. I'm actually just going to copy this, and then I'm going to run osquery. So let's do that. Run osquery. And let's go ahead. So you see, I have it saved here. Check for first shell established. So osquery can show you open sockets. So if this attacker was successful, if they open a reverse shell and it's still established, this is what I'm looking for, to see if they're actively live in our system right now. All I'm going to need to substitute is that remote port and that process ID. Just copied some additional stuff we don't need for the query here, so just take those off and submit. Now, fingers crossed, I shouldn't have any results. If I have results, that this is a live established session, which my attacker has. So hopefully our preventions worked and this wasn't successful. If we look at the status, we have 0 result rows. So thankfully there isn't existing established session. It doesn't mean we're in the clear, right? This attacker got very far in. So we have to see what those other alerts are saying. You might be asking, why are there 3 instances? So this rule is that endpoint behavior rule. These other 2 are actually our SIEM rules. So with the data that we're collecting, we have the same similar rule running in the SIEM, and we've detected it there as well. So just to highlight that, again, defense in depth concept, one actually was preventative. What else do we have? So it seems like we can actually get a lot of detail out of what the attacker sent to themselves in Slack. So you see, this machine is yours. If a reverse shell is not successful, looted files will follow, which basically means stolen files might be exfiltrated. And we have another alert here for possible data exfil using Slack. And this time, it seemed they used the file upload API of Slack to send this loot.zip file. Which, if we look here, what's going on, they copied our shadow file, our passwd file, SSH keys potentially. Remember, we saw an alert for SSH key modification files, and AWS credentials. That's not something you want to see. Just based on the posture that this organization have, we've seen already a lot of icky stuff already. Seeing AWS keys on this machine is probably not a good sign. But the attackers tried one more thing here. They tried to ransom us as well. So probably ticked them off that they couldn't get the reverse shell, and they tried to ransom us. This is using dark radiation. This was a group that was discovered and reported on by Trend Micro. Very in-depth blog article by them, by the way. But if we look here, thankfully, again, this was prevented with our rule detection, behavior rule prevention, right? Now, I can immediately tell that this wasn't successful, because if it was, as part of this session, this xargs process would have child processes running OpenSSL. And we don't see that, thankfully. Even though, because we can see the arguments, we would have been able to see the attacker password, unless they hid it. But I'm going to show you how we can actually see those successful results. Again, I'm not going to hide anything. Going into table, we actually have a field for the actions that were taken. Not that one, I should say responses is what I'm looking for. Yeah. So you can see we have a response action of kill process, and it was successful. We kill both the process, so xargs in this case, and the parent process, which is that pawn check script this attacker was using. Technically, this is going to stop everything else from running. So we shouldn't see now what was part of the initial log4shell exploit string. So we're probably not going to see the script being deleted because we killed their script, which basically means we killed everything. And we don't. Okay, let's take a breather. We've just discovered a lot of what happened now. We've been through most of those alerts because they were all through the session. I think it's time and warrants a case update. Also, I'm going to ask the team in the case if we should take this host offline, because attacker got in, they can get in again because we haven't patched Java, and they might keep doing stuff. And we can do that because as Elastic, we have the host isolation options as part of our endpoint protection. So we can see here I have the option to isolate host. Now, I'm going to take the stance that my organization, their procedures do not just randomly allow me to isolate production Java hosts, right? Keep that in mind. To do this properly, you're probably going to have a couple of lines of approval as part of your security operations workflow. You might not, that's up to you. In this case, I'm taking the stance that they are. So we're going to go back to our case. And we're going to say that dirty pipe was exploited, attacker exfiltrated data. What would you like me to do? Based on the other alerts seen attached here, an attacker successfully exploited dirty pipe via log4shell to get root access. They then exfiltrated files via Slack. Ransomware and reverse shell attempts were stopped by endpoint prevention. Should I take action to isolate this host considering the above? question mark. So we're just going to add that to our case. Again, you might want to leave another table showing the files. You might want to leave a screenshot of the session viewer, right? You can do that. You can host images somewhere and have them using the markdown syntax. I'm going to update the Jira issue, and I'm going to wait now to see if anyone responds that I should isolate the host. There's a couple of things I want to do before I wrap up my portion of the investigation. I'm going to go back to alerts and go to my acknowledge queue. There's a new open alert as the time I'm recording. Let's look at this in full screen. So we covered these, we covered this, we covered these 3 malware alerts, we covered the potential reverse shell activity. This is probably related to what we saw as part of the, taking the files and sending them over Slack. We can actually check that. So there's a view we haven't spoken about yet in this demo, which is our event analyzer view, which instead of like session viewer showing me processes spawning off of each other like I was in the terminal, this is going to be a bit more graphical. This is going to show me process lineage in a very graphical way. So we're just going to let that load to see what happened. So again, we go all the way up the chain. We see Java, that start Java process. We see a bunch of sh, that pound check script, and then this copy command. Yep, this is essentially taking those SSH keys that we saw, and we can see that file was created. So they took them, right? They took the authorized keys file. But they didn't take any private keys, it seems, just the authorized keys file. So we've covered that, we covered dark radiation, we've covered possible data exfil using Slack. We are yet to look at this though. Is it related? Because it happened quite a bit after. AWS IAM deactivation of MFA device. So this is moving from endpoint data to cloud events. So within one of my remote clusters, I'm actually ingesting AWS CloudTrail events. And we have a rule which says, let's look at it, that let's open up the rule context to see what this is looking for. But by the name, I know it's not going to be good, right? And because I saw those AWS credential files taken, I can pretty much see where this is going. So this is looking for someone running deactivate MFA device or doing that through the console. And again, there's a bunch of other information here. I'm highlighting this rule as well, because this was a community contribution. Shout out to Austin Songer. This is one of the ways that the community can give back. Our detection rules are all open on a public repo. This was a community contribution. So kudos to anyone who's ever contributed to our rules. So just going back to my alert view, this is saying that this source address for this user, which is my user, deactivated MFA. Now, this is showing this user potentially based on my assumption. I'm going to hypothesize that this is the same attacker, because it's not a coincidence, using the stolen AWS credentials. There's some things we can check for that, right? So I'm going to use timeline for this actually. So I'm going to go ahead and close this window. There we go. And what I'm going to do is I'm going to use the timeline now. This isn't what I want, so we can clear that. And remember that source IP? So I'm going to filter for CloudTrail data. Event.dataset actually. Well, I'm going to make it easier. I've previously run this. And see the full CloudTrail details. So this is the raw event, and this is the actual detection rule, the result. But what is the source IP? What does it do? So I'm just going to take off these specific event actions. See how I'm using timeline to just really quickly switch. And let's see what else this person did. Well, what do you do before you find out? Actually, let's go in ascending order. This is from today. Let's be a bit more specific. Let's go to June 24th. So again, you see, going through the whole investigation, because whatever this person's doing from that source IP is a lot, and I'm not really happy with what I'm seeing. So let's go to the 24th, which is the time of the attack we were investigating. Let's narrow it down even further, right? It was between 10:30 and 11. Update. Yeah, so you have list access keys and list MFA devices. You also have the deactivate MFA device, get role. What does this mean, right? So if I'm someone who has stolen AWS keys, which we've seen through the session view, I'm going to check what keys they are, who they belong to, which is how I'd know to deactivate the MFA device. I'm going to list their MFA devices, and I'm going to deactivate it, which is seemingly what this seems to have happened here. So again, what do we think has happened here? So actually, you know what? I'm going to filter down further to just this user, because I do have legitimate AWS traffic that might be occurring here. And I'm going to add this to my case. I'm going to add the timeline now to my case. So let's save it. AWS credential theft and IAM activities. So we see how, they grabbed that key and they started to do this. It's not what most would consider lateral movement, but it's as close as lateral movement to they might get, right? This is actually worse, in my opinion. So this attacker was pretty smart. So instead of living on that machine and just scanning ports and a bunch of stuff which might trigger other rules, they stole keys to work in their environment to do whatever they want. Again, just seeing the bad posture this organization had, their AWS account is not secure. At least they're collecting CloudTrail logs in Elastic. So let's attach this timeline to the case, add to an existing case, our currently critical open case. And yep, let's add that timeline. Based on the AWS alert included here and what we saw in the data exfil attempt, it seems like the attacker might have taken and used the AWS keys to disable MFA, so multi-factor authentication for that user. Evidence attached. Okay, one more thing I'm going to do, and then I'm going to wrap up here. Two things, because there's some features I still want to show. One is, remember the source IP? Should we get more information about it? Because we don't know if it's our attacker IP, right? So there's a couple of things I would do during an incident. I'll let this page load, but something else I'll do during an incident, I'll use my terminal, right? I still have my terminal available to me. Remember how in our session we saw a reverse shell attempt to images.swiftcrypto.com, and they also downloaded the log4shell exploit from images.swiftcrypto.com? What does that resolve to? And let's look up images.swiftcrypto.com. Lo and behold, it resolves to 35.198.74.222, which is, of course, a machine the attacker has access to because that's where they've loaded their payloads. That's where they try to open a reverse shell session 2. So now it looks like they're trying to log in from AWS from that machine. So again, obviously use everything you can from Elastic, but this stuff is just as helpful, right? One last check that I'm going to do, and one last thing, is I'm going to run one more search because I want to know which firewall rule allowed those Slack messages to be released, because we probably want to get that adjusted. We probably don't want to allow that traffic from this specific Java production machine. Now, in one of my clusters here, I am collecting my Google Cloud Firewall logs. So I'm just going to do, I'm going to use timeline to do a correlation search to see what that was. I have this saved here because it's something I hunt for regularly. Under correlation, a bit different to what we saw before. This time what I'm going to do is, so we know we had a successful TLS connection coming from the machine, right? So the network packet capture data. I'm going to correlate that with the destination IP. Actually, this should be improved. Max span 2 minutes. So I say, hey, within a 2-minute time period, show me if, not if, because we know this is going to be successful, but the corresponding event on our firewall when this TLS connection happened. And we can see here, yes, correlated by the destination IP. Again, thanks to our TLS data, we know this was Slack. And this is my firewall rule data. So Google Cloud Firewall, if you live in Google Cloud, it provides excellent details. And you can actually see, for those of you familiar with our cross-cluster search syntax, this is living in our cross-cluster search cluster. And we'll be able to load up the exact rule here. So rule name, so this James log outbound, it's allowing all, IP protocol all to all. So again, bad posture, allowing everything outbound from everywhere. So we now know what rule allowed this traffic to happen, this traffic to occur. I said this was the last search we're going to do. I'm going to actually run one more because I just remember there's one more feature I want to show you. This cluster, apart from having access to other clusters, uses one of the amazing Elasticsearch features called Searchable Snapshots. What is that? As we know, as data ages over time, we might not want to have that all live live active on our expensive hardware or cloud hardware, which is running our cluster. It's very common that you'd have what we call an index lifecycle management policy, which grabs that data and after a couple of days or months, moves it off into slower hardware and then eventually archives it. Now, before searchable snapshots, there was no way you could search that archive without restoring it. So you'd have to go through the whole process of reaching out to the right team, saying we need to restore this snapshot from X years ago, finding out what snapshot that is, making sure you have the right resources within the cluster to be able to restore it, wait for it to restore, and then search it. Well, what I'm going to do is I want to see if I've seen that IP, 34.198, whatever it was, in my archive, because maybe this attacker has been in there before, over the years. Let's do that. Let's run that search. So I'm just going to grab that IP again because I don't remember what it was. I have it here actually in my terminal. And to do that, using timeline, really simply, let's create a new one. I'm going to look how easy this is. So I'm going to do source.ip is, destination or source is that IP address. So this is a search, it's searching that date range. But if I want to search over the last 5 years, let's do that. Last 5 years. As an analyst, this is all I care about, right? I don't care that it's on an archive. I don't care that it's a searchable snapshot feature. I just need to run my business as usual activities and search for the data. I can see within the last 5 years, there's quite a few events from this IP, which if we sort in different order, we can see when that actually started. Now, this searched our entire cluster and that archived transparently. All I did was change the time range, right? To show you a little trick, because I am sharing tips and tricks here, if you want to have as part of your operational procedure that specifically asks analysts to search frozen archives, so searchable snapshots, we have a tier field. So I'm going to search, this time changing it to tier frozen. And let's see the results there. So within our frozen data, we had 1,278 events. So actually, because this detector is very active now, we have a lot of activity over the past couple of months. Anything older than 90 days, that within this cluster in particular, not my remote clusters, because remember, my remote clusters probably aren't using frozen at this point. This data now lives in the frozen tier. So none of this is actually live. And you saw how quick we got that back even though it's searching an archive, and he saw how easy it was to do that. Yeah, we can see we've had a lot of events across multiple machines to and from this IP address. So not great. This attacker either persisted in our network a while and we only spotted it now. Maybe we didn't have the right rules in place before. Maybe we weren't looking properly. Who knows? But thanks to this search, we're able to say how much activity they've actually had over the years. I'm going to save this and add it to the case because this obviously is a very significant finding. Attacker IP over last 5 years frozen. Save that. I'm going to attach it to our case. And I think my part of this incident investigation is done. What's next is people are going to confirm as part of this case if we should take that host offline. We're going to want to patch this machine. We're going to want to harden our firewall rules. We want to do all of this. But I really wanted to show everything that you have available to you. We actually scratched the surface. There's so much more we can talk about the Elastic security, but I really wanted to go through a whole incident investigation. We took almost a full hour, if not that. Didn't hide anything. A full product demo as if I was using it live in a security team today. And this is how people are using it. So hopefully you found this useful. I'm just going to leave my last comment here. This is what the attacker has done in our environment over the last 5 years. Confirmed this IP resolves to images dot, actually let's make sure this isn't clickable, swiftcrypto.com that we've seen in the alerts in this case. Add that comment, and I am wrapping up here for you today. Again, I really hope you enjoyed this. I actually really enjoyed going through it and putting this whole thing together. If you have any questions, I'm going to link our Discuss forums, our community Slack. Find us there, ask us questions. I'm going to link a trial to Elastic Cloud. I'm going to link our detections repository. So it's all going to be there, readily available right from within this video. Thank you all very much for watching. It was a long video. I don't usually have videos this long. And I really, really hope you enjoyed it. Till next time.